I want to tell you about a prison with no walls, no guards, no locks, just distance. Thoughtful. Our galaxy is about 100,000 light years across. It contains somewhere between 200 and 400 billion stars, and any civilization trying to explore all of it, moving at any speed physics allows, would need longer than the current age of the universe just to visit a meaningful fraction of those stars. The galaxy is not waiting to be explored. It is actively, mathematically, permanently resistant to full exploration, and I think that changes everything about how we should think about alien civilizations and what they're actually capable of. Curious? Let me show you why, and let's do this with real numbers, because real numbers are the only thing that cuts through wishful thinking. The galaxy is 100,000 light years across. That is not a vague estimate. That is a carefully measured figure based on decades of astronomical observation. Light moving at 186,000 meters per second, the fastest speed anything in the universe can travel, takes 100,000 years to cross it. 100,000 years of travel at the maximum speed the laws of physics allow. Now let's think about a spacecraft. Not a real spacecraft we've built, because those are far too slow to matter here. Let's imagine a spacecraft moving at 1% of the speed of light. That would be roughly 6.7 million mph. It is hundreds of times faster than anything humans have ever built. It is an engineering achievement we cannot currently come close to, but let's grant it. At 1% of light speed, crossing the full width of the galaxy takes 10 million years. 10 million years. The dinosaurs went extinct 66 million years ago. So we're talking about a journey whose duration is about 1/16 of the entire reign of the dinosaurs for one crossing of the galaxy one way at a speed we can't achieve. And that's just crossing it in a straight line. Exploring it, actually visiting individual star systems, examining planets, looking for life, collecting data, is a completely different scale of undertaking. Because the galaxy isn't just wide, it's dense. With 200 to 400 billion stars scattered across that 100,000 light-year disk, you can't just fly through in a straight line and call it explored. You have to visit things, stop, look, move on. If you wanted to visit every star in the galaxy, just fly past each one, spending no time at any of them. And if you moved at 1% of the speed of light, the math becomes almost absurd. With an average spacing of about 5 light years between stars and hundreds of billions of stars to visit, even the most optimistic routing would take hundreds of billions of years. The universe itself is only about 13.8 billion years old. A complete stellar survey of the Milky Way at 1% of light speed would take many times the current age of the universe. Let that sit for a moment. The galaxy has existed for about 13 billion years, and in all that time, no civilization, not even one that started exploring on day one, has had enough time to visit every star. The math doesn't allow it. Now I can already hear the objection forming. What about faster speeds? What if a civilization achieves 10% of the speed of light or 50%? Does that change the picture? Yes, it helps, but not as much as you'd think. At 10% of light speed, the minimum crossing time drops to 1 million years. That's genuinely better. But now you're 1 million years into your journey, and you've crossed the galaxy once. You haven't explored it. You've passed through it. And a complete survey of all its stars still takes billions of years because the number of destinations is so enormous. Even at 90% of light speed, the fastest any physical object with mass could realistically aspire to, and far beyond anything we can currently imagine building, a full survey of the Milky Way stars would take tens of millions of years at minimum. The galaxy is just too big and too full for any speed to make complete exploration feasible. And this applies to every civilization, not just us, not just civilizations at our level of technology. Any civilization anywhere in the galaxy, regardless of how long they've existed or how advanced they've become, faces the same mathematical wall. The galaxy is older than any civilization we know of, and it has never been fully explored by anything. So what does this mean? It means that right now, today, there are almost certainly vast regions of the galaxy that no intelligence has ever visited. Enormous stretches of space, thousands of light years across where stars have formed, lived out their entire lives and died without any observer ever coming close enough to notice. That is a staggering thought. 400 billion stars, and the overwhelming majority of them have never been visited by anyone ever. Now, I want to connect this to a question that has fascinated scientists for decades, the Fermi paradox. Enrico Fermi, eating lunch one day, asked a simple question. If the galaxy is old and if intelligent life can arise in it, then why haven't we seen any evidence of a galactic civilization? Where are the alien megastructures? Where are the signals? What is the evidence that someone somewhere in our galaxy has been busy building and expanding and exploring? People have proposed many answers to this question. Maybe civilizations destroy themselves. Maybe they go quiet, maybe they're hiding, maybe they've transcended physical existence, but one answer doesn't get enough attention. Maybe no civilization has had time to reach us yet, not because they don't exist, but because the galaxy is so large that even a civilization that they started expanding 1 billion years ago might not have spread far enough to reach our small, quiet corner of the Milky Way. Think about it this way. Our solar system is located about 26,000 light years from the galactic center. We're out in one of the spiral arms in a relatively uncrowded neighborhood. If a civilization started expanding from the galactic center 1 billion years ago, moving at 1% of the speed of light, they would have spread outward about 10 million light years by now. But wait, the galaxy is only 100,000 light years across, so they should have covered it many times over, except that's not how expansion works in practice. You don't expand in a clean sphere, you spread unevenly. You settle certain star systems more than others. You leave gaps. You slow down in regions with fewer resources, and as you expand, the civilization at the frontier has less and less connection to the civilization at the origin. Communication across 50,000 light years takes 50,000 years. Even at light speed, you can't run a coherent empire across a galaxy. You can barely maintain contact. So even a very old, very expansive civilization might not be a unified galactic presence. It might be a scattered collection of isolated colonies, each evolved independently over millions of years, each barely aware of the others, each essentially a separate civilization by any practical definition. And some of those colonies might never have reached us. Our corner of the galaxy might genuinely be unexplored territory, not because no civilization exists, but because no one has had time or reason to come here yet. This is called the locality hypothesis, the idea that every civilization is fundamentally local, bounded by the light-speeded limit on communication and the energy limit on travel, and that the galaxy is simply too large for any civilization to have a genuine presence across all of it. I find this hypothesis compelling, not because I want it to be true, but because it follows directly from the physics. When you take the actual numbers seriously, the distances, the speeds, the energy costs, the time required, you get an answer that doesn't require any exotic explanations. No civilizations hiding, no civilizations destroying themselves, just physics doing what physics does, enforcing limits quietly, permanently, without exception. Now let's talk about probes, because someone always brings up probes at this point, and it's a fair thing to bring up. Probes are smaller than crewed ships. They don't need life support. You could potentially accelerate them to much higher speeds using technologies like laser sails, where a powerful ground-based laser pushes a lightweight sail across the void. In theory, a tiny probe on a laser sail could reach 20% of the speed of light or more. That's fast, and it doesn't need fuel for the journey because the laser does the pushing from behind. Could a civilization build enough probes to survey the whole galaxy? Let's do the math. At 20% of the speed of light, visiting one star and moving to the next takes on average about 25 years per star-to-star hop, given the typical 5 light-year spacing. To visit 400 billion stars sequentially would take 400 billion 25 years. That's 10 trillion years. The universe is 13.8 billion years old. So sequential probe exploration takes roughly 700 times the current age of the universe. Fine, you say, don't do it sequentially. Launch many probes in parallel. Launch millions of probes. Each explores a different region. But now you're talking about building and launching millions of interstellar probes, each one requiring enormous energy to accelerate, each one needing a powerful laser array. The energy and manufacturing requirements for a galaxy-wide probe network are almost incomprehensible. Even for a civilization with stellar-scale energy production, equipping millions of probes with enough speed to be useful across the full galaxy is an undertaking that strains even the most optimistic estimates. And then there's the communication problem. Each probe, when it finds something interesting, sends a signal home. That signal travels at the speed of light. If the probe is 50,000 light years away, the signal takes 50,000 years to arrive. By the time the civilization receives the news, 50,000 years have passed. The civilization has changed. The context of the discovery has changed. The people who designed the mission are long dead. A galactic probe network doesn't give you real-time knowledge of the galaxy. It gives you a 50,000-year delayed, incomplete, fragmentary snapshot of regions your civilization sent probes to many thousands of years ago. It's better than nothing, but it's very, very far from the complete galactic map we imagine in science fiction. So where does all this leave us? It leaves us with a picture of the galaxy that is very different from the one we grew up with in our stories. The galaxy is not a neighborhood. It is not a community of civilizations trading information and visiting each other. It is a vast, ancient, mostly silent place where life almost certainly exists in many locations, but where the distances between those locations are so enormous that meaningful contact between them is the exception, not the rule. Where full exploration is not just incomplete, but mathematically impossible. Where every civilization, no matter how old or advanced, knows only a tiny patch of the whole. And here's what I find most interesting about that picture. It means the universe is fundamentally mysterious. Not temporarily mysterious, waiting to be explained once we get smart enough or explore far enough. Permanently mysterious, because the information about most of the universe is physically unreachable. It exists, it's out there, but the distance and the speed of light conspire to keep most of it forever beyond anyone's grasp. That's not a failure of science. That's one of the deepest things science has ever discovered, that the universe contains truths that no intelligence, no matter how ancient, no matter how capable, can ever fully access. The galaxy will always have unexplored corners. The universe will always have unreachable regions. Mystery is not temporary here, it is structural. I find that beautiful in a strange way. Not frustrating, beautiful, because it means there is always more. There is always something beyond what anyone knows. The universe doesn't run out of secrets just because a civilization gets smart enough. It is deep enough to hold its mysteries forever. And for those of us who love the process of discovery, who get excited not just by the answers, but by the questions, that is a remarkable gift. Now, I want to say one more thing, because I think it's important, and it often gets left out of conversations like this. Even though no civilization can explore the whole galaxy, exploration is still worth doing. Every star visited is a star known. Every planet examined is a world understood. Every data point collected adds to a picture that, while never complete, is always growing richer. The incompleteness of the project doesn't make the project meaningless. It makes it endless. And an endless project, a project that can never be finished because the universe is too large and too deep, is actually a very good thing to have. It means there is always a reason to keep going, always a next star, always a next question, always something just beyond the edge of what you know. The galaxy cannot be fully explored, but it can be explored forever. And that is more than enough. We are at the very beginning of this. We have not visited another star. We have not even left our own solar system in any meaningful way. And yet, from right here, we have mapped the structure of the entire observable universe. We have detected planets around stars thousands of light years away. We have traced the history of the cosmos back to within fractions of a second of its beginning. That is not nothing. That is an extraordinary start. The prison with no walls, the one made purely of distance, is real. It will always be real. No civilization escapes it completely. But inside that prison, there is still an almost infinite amount to do, to see, to understand, and to discover. And we have barely started.